Hello, this is video number 14, and we're still looking at the source code files for the OilField project, the one that solves the OilField heavily recursive non-trivial problem. This one is oilfield.cpp, the implementation for the OilField class. Let's see what we got. Comments at the top, of course, we've got to include oilfield.h, the header file, the interface. Constructor, destructor on lines 11 and 12. Not much to see here. That's just empty curly brackets at the end of the line because neither one of those has to do anything. Now, it's not necessarily the case, but it does kind of mildly imply that there must not have been any dynamic allocation going on, dynamic memory allocation. Otherwise, we better not have an empty destructor or we might have a huge memory leak. So this is just going to use the private variables as are. We don't have to worry about pointers and new and delete and all that. Maybe that's a mild relief. The mutators, let's go. Read says, read the contents of a grid array from an open file, convert the array. Remember, we're going to convert it to zeros and ones, so we don't have to look for @ signs and stars and all that. Those are just ugly. I've got a pretend oil.txt file up here, by the way. 2 rows, 3 columns, and I think that's the example I used when we first started talking about OilField way long ago. I put dots down at the bottom because there could be other regions in there, but we're just going to focus on this one region with that set of values. Okay, so here we are. We're in read, and they passed in a reference to an IF stream that's called input locally, INPT, with no U in it. I could have just put that in. It would have made any difference, I don't guess. Line 22, read rows and columns. Now look at this. This is the first time we've seen that. Line 22, look at the syntax of that. That's reading in from INPT, our input file stream, just as it would read from CN. And we don't even have to prompt. That wouldn't make any sense. We don't print a message on the screen that says type in the rows or anything because we're getting that directly from the input file. So I guess it's kind of a trace here. I'll wing it. Rows. We're reading into private variable rows inside this OilField object, and it reads in the first thing in the file. Now here's part of why we've got to pass in these input file stream things by reference, because that, remember, this is going to be copied into a bounded buffer in memory, and that bounded buffer is going through the bytes and it's not going to go backwards. So we just now consume the 2 out of the bounded buffer. So when it gets to line 23, input into columns, it doesn't go back and read the 2 again. That would just be silly. It picks up where it left off. So we do need that internal cursor to keep up with where the next byte is when a read comes around again. So that reads in the 3, and the 3 has been consumed, and now we're ready to read the meat of the tomato down there and get the ats and the stars and all that. Now, pause and reflect. Do we actually have a region that we can use here? That's what line 24 is doing. I'm sorry I'm not writing these down, but I hope they're straightforward enough that we can just discuss it, shall we? Line 24, if exclamation point rows. That's the C++y shorthand way for testing to see if rows is equal to 0. So if not rows or not columns on line 24, that is precisely equivalent to this. Listen carefully. If rows equals 0 or columns equals 0. If either one of those is 0, if we've got 0 rows or 0 columns, then we don't have a region to work with. There's nothing there. It's completely flat. So it's a kind of double testing for the sentinel, isn't it? If we read in rows and columns, certainly if they're both 0, then that condition is going to be triggered. But if either one of them is 0, it's going to return false on line 25, and we're out of here. Okay? I hope I didn't go through that too quickly. We could discuss that in more detail on office hours if we need to. Line 29 is a call to a member function. We're still inside the object. It hasn't returned to the main program yet. We're still inside the object. And set grid array to all zeros. From line 29, let's drop down and look at line 50. There's the clean function. Set all elements of a grid to 0. And look what it's doing. A nested loop. We use nested loops all the time with 2-dimensional arrays. Line 51 is going to go through all the rows. So what it's going to do is freeze a row number at 0. The inner loop for C, that's going to go across all the columns. So if I do a fig here, I'm not going to do 100 by 100. I'm sorry, I'm just not. I'll be lucky to draw enough straight lines for just, that's, you know, that's not bad. Those are pretty straight lines. I don't know what skill I'm using or convention or algorithm or whatever, but that is, I'm so impressed with that. That could be an American flag. Okay, not only that, but columns. Oops, those are getting a little wiggly. Imagine 100 by 100. You can extend this in your mind up to the full max width, max height. In our two-dimensional array defined back in the header file, dot, dot, dot here, dot, dot, dot there. It's going through this entire grid, and I'm not even going to fill it in. It's setting absolutely everything to zeros. Start over. We're about to read a new region into our grid. So it's going to start over. And it goes through the whole thing. Row equals 0 as long as row is less than max height. The same like with a regular array. I mean, for I is 0, I is less than size. You stop at less than size because the index number is 1 less than the maximum index. I mean, 1 less than the dimension. And on line 53 is just setting, there is our assignment statement, grid RC. For the row and column, it goes through all of those, every single one at a time. And I'm in a loop as well again. Set 0 to all those. Okay. Then it comes back to line 29. Convert input to zeros and ones. Remember we're going to do that? As we read them in, we're not going to leave them ats and stars because those are hard to work with. Now here's a deal. In setting inside a bouncy wall of zeros. Observe this. If you believe me, that, okay, let me put some index numbers up here. 0, 1, 2, 3, 4, 5, 6, 7, yada, yada, yada. This is columns, column number. Here's row number. 0, 1, 2, 3, 4, 5, 6. Now, we're going to have a bouncy wall by default. We don't have to do anything magic to make a bouncy wall. This whole thing is one gigantic bouncy wall. If we are careful where we put that region inside this grid, it will keep the bouncy wall. We'll automatically have a bouncy wall because everything that you see on here, every one of those little squares has a 0 in it. Bouncy wall for free. How do we make that happen? Well, look at this. Char temp, character variable temp, local variable, in the stack, all these things. For int, look at line 33. Oh, so carefully. Int r equals 1. I'm even going to put that over here. This is going to be much more of a trace than I had originally intended. R is 1, not 0, for the beginning of that for loop. And we're going as long as we're less than or equal to rows 2. So it's not going to go very far, is it? It's going to go R is 1, R is 2, and then it will drop out of that outer for loop. The inner for loop, C equals 1. C equals 1 as long as C is less than column. So it's going to loop C is 1, C is 2, C is 3, equal to columns, and then it will fall out. Now watch this. So far, we're inside the first for loop on line 33. We're inside the second for loop on line 34. Let's get busy. Reads from input. The cursor is going to say, okay, you're ready to read an @ sign. And it reads an @ sign into temp. That's consumed. Exit out. If, on line 36, if temp is exactly equal to the oil char, and I believe it is, it's exactly equal to the oil char, then what we're going to do? We're not going to store the oil char. We just take a peek at it. We read an @ sign from the file, and we look at that. There's oil there, so I need to put 1 in the grid, and that's exactly what happens. 37, look at this. It puts a 1 at row 1, column 1, this right here. Why? Why didn't we read it into slot 0, 0? Why did we start those loops the way we did? Because we want to be inside that protective bouncy wall. So we leave that as 0 up here. Leave that entire top row zeros. We're not going to touch it. This entire first column is zeros. We're not going to touch it. What are we going to touch? Well, it skips the else. So we're now nested for loops. It goes back to the C loop first and sets C to 2. And it asks, is C equal to 2? Is that less than or equal to columns? In fact, it is. input into temp, the next thing to read is the star. So it reads over the at and puts the star or the asterisk. If temp double equals oil char, temp does not equal double equal oil char, so it does not set grid RC, in this case 1, 2, to 1, it sets it to a 0. Now notice we get away with an else here because there are only two possibilities. I don't have to test specifically for the asterisk, the star character, because there are only two possible input characters. Your mental note here, your program 2 is going to be a little different. There are more than two things that could show up in your grid. Just put that off to the side for when we have to know it. Grid RC equals 0. Grid RC, 1, 2. Row 1, column 2, and that's going to be a 0. Moving right along, C goes up again. C is now 3. Is the column less than or equal, I'm on line 34, is the column less than or equal to cols? Yes, it is. 3 is less than or equal to 3. So we read in another character, we read in the @ sign. Since we read in the @ sign, the condition on line 36 is true, and it puts a 1 here. Okay. Now, at the bottom of the inner for loop, C is incremented, it's up to 4. It tests the for loop condition on line 34. Is C less than or equal to columns? No! No, it is not. C is not less than or equal to columns, it's more than columns. So it falls out of the inner for loop, which means it goes back to the second iteration of the outer for loop. So after all this time, it finally pluses R, and R goes from 1 up to 2. See how this works? 2, let's check at 2. Is 2 the condition on line 33? Is that less than or equal to rows? In fact, it is. So look, when you hit a for loop from above, every time it starts all over again with the initialization statement. So C is going to get set back to 1. Is 1 less than or equal to columns, it asks on line 34. Yes, it is, so it moves in. And you can see what it's going to do. It's going to read in, whoops, I forgot to X that out. It's going to read in the next character another at on top of the old at. Reads that into temp. Is temp equal to oil char? Is the asterisk equal to oil char? Yes, it is. So it reads a 1. We see what's going on here. You can trace the rest of these if you want, but it's going to read that in and translate all of the stars into zeros, translate all the ats into 1s. And now I can put this double bar here. That's our entire region. And here's what I meant by why we don't touch the top row column or anything. All of these, when we called clean a long time ago, these all got set to zeros. So we've automatically got a bouncy wall around this whole thing. No special steps required. We actually have a lot more zeros that we need, but notice this will put a bouncy wall. This will accommodate any size region that we read in that will fit in our grid. So that was on purpose. We meant to do that. That's why, do a contrast and compare. That's why the nested loops on 33 and 34, those start at 1. So we're offsetting to inside our grid, even though clean started at 0. Clean is wiping this whole thing clean for another iteration, but it starts at 0, 0 because we want to be able to have that automatic bouncy wall. Now then, you might think, you know, that clean thing, that feels an awful lot like something that ought to go in the constructor. You know what? I would agree with you. I originally did that. You know what happens? If you put that in the constructor and only do that clean stuff, set it all to zeros one time, then you got a problem. Because you'll have leftover garbage in here when you try to read another region out of the same input file. So yeah, I had to take that out of the constructor and make that a separate function. So it gets called every time we're starting to read another region. After we're done finding oil deposits in this, then we're going to have to go back and reset everything to 0 for the next region that comes along. Duh! Why didn't I know that? Why didn't I see that coming? Who knows? Okay. I think we've done the read. Yeah, we've read the whole thing. Returns true because it was able to read something. It's returning success or failure. And that, remember, is what is governing the behavior of the while loop back in the main program. Every time we call read and it returns true, that means we just now read in all this stuff into a grid and we're ready to start looking for oil. Go to the next step. Now then, the big one. The big one is called dry up. Let me read these comments, see if I misspelled any words. Dry up this pocket. This is taking a local view. I'm on line 58 and now 59. Dry up this pocket and its neighbors recursively. We've traced through an example of that before there was any code. Constituting one complete deposit in an oil field. So all of the connected pockets, remember, all of those together constitute one deposit that's separated geographically inside the grid from any of the other deposits. Now, on mine, unfortunately, my hard copy, it splits, but I think I can remember. Pardon me. Line 65 is the base case, and the base case is split over 2 pages. Exclamation point grid RC. What on earth is that asking? It's exactly equivalent to this condition. If grid RC, the row and column that got passed into me, the coordinates that were passed to this function, if that grid square is a 0, that's what that test is. If grid RC is 0, grid point at this row and column is 0, then turn the page, find out what happens, then return 0. It's not part of a deposit. Okay, if I'm still here and I survived and I'm on line 68, then the grid square must be a 1. In this particular example, that's the only remaining possibility. In your search for a needle in a haystack, there's more than one possibility, so be careful about that. Recursive case. If we're still here, then we got to dry up this oil pocket right away. We don't want to get an infinite recursive loop. Then check the neighboring plots. RC is 1, so start the chain reaction that sets the entire deposit to zeros. And then returns 1 to indicate that we've dried up that one entire deposit of all those connected plots. And look at that, line 72. We dry that up immediately because not only have I now taken into account that I have oil here, I'm going to be somebody else's neighbor. Actually, I'm going to be a neighbor to all of my neighbors. And I don't want them to come back and look at me and say, oh, look, some fresh oil here, because that's already been taken care of. Look at all the recursive calls. Good heavens, this is easily the most recursive thing we have ever seen in our young lives. Well, your young lives. Line 73. How do I go up to the left? Well, I subtract 1 from the row, subtract 1 from the column, and look at this, what it's going to do. You might think, danger, danger, I could run off the grid. No, I'm not, because I'm not going to pass in a bouncy square, and it's not even going to try to move up off the bouncy wall. The first square I'm going to pass in is this one right here. So when it goes up to the left, it's going to go here, hit the base case, and come right back. If that doesn't make any sense, I would say go back and watch that video where I went through that lengthy, long, drawn-out example with a great big grid, all that stuff. That has to make intuitive sense before this code is going to make heads or tails at all. We'll go up and left, and you can see how we calculate the coordinates of all the neighbors. And I just lined them up in columns like that so you could compare it to the previous call. Up and left, and then up and right, and that's all 8 neighbors. So I look at all 8 different neighbors, and when I'm done, notice I'm not even asking whether or not the neighbors have any oil. I don't care. They could be a 0 when I first get there, they return immediately. They could be a 1 when we first get there, and they start their own recursive chain reaction. It doesn't matter. I don't care if this deposit has 100 plots in it or if it only has 1 plot in it. My count is going to be exactly the same. And that's what line 81 represents. Line 81 says, I don't care how many squares you just got through drawing up recursively all over the map. You're still, if you're all connected, you're only one deposit, and that's what it's returning. So the return value from dry up that goes back to the public wrapper represents how many deposits just got dried up. It's either going to be 0 or it's going to be 1. Okay. I don't know what else to say about those. List your questions off to the side. As you know, I'm just blabbering all kind of stuff here, and if I want to keep this example on the board, I can't write all that stuff. Oh, I do want to point something out though. You know what? Line 73, 74, 75, all of those are returning something. They're all returning 1 or 0. Why are we ignoring the return value from those recursive calls? Because we don't care. If I go up here and that's a 0 and it returns, I don't care that it's returning a 0. I'm looking for this deposit that I'm drying up here. I go up here, it returns 0, I don't care. That one's going to return 0, that one's going to return 0, that one's going to return 0. Look at this one's going to return 1. I don't care about that either. I don't care what your return value is. All I'm trying to do is dry all y'all up that are in the same deposit with me. So this, even though it has 2 1s in it, it will eventually, when we finally get to the bottom of this, so to speak, on line 81 and return back to the public wrapper, it returns 1, and again I'll say it, that represents the entire dried up deposit no matter how big it was. Maybe it'll make more sense when we look at the public wrapper. Find all deposits, comment on line 83. Find and count all oil deposits in a grid. So this one's going to need a counter. Note, this is still considered a public wrapper function. It's going to jumpstart the recursion, even though the private function it calls is not an overload. It doesn't have the same name. Dry up sounds more like I'm looking at one square here. I'm going to dry you up. Whoever lives at row R and column C. Find all deposits has the global view, typical of the public wrapper. And look at this. Deposits equals 0. That's your counter variable. Counter variable starts off at 0. I haven't seen any deposits in this entire region yet. Look at the nested loops. Why do they start at row 1, column 1? Because we're not looking at the bouncy wall. This is the first square we look at. And if you trace through those loops, it looks here. Are you part of a deposit? This one's going to return yes. Yes, I am. So there's a 1. Then it goes to this square. Are you part of a deposit? It asks. No. So I don't add 1. This, are you part of a deposit? Yes. And then it will add 1. Look at this. Every time I get a return value from dry up on line 92, regardless of whether it's 0 or 1, I add that to my counter. Deposits equals deposits plus dry up RC. And it's looking at every single square in the real part of the grid, not the bouncy wall. Offset again, start at 1, 1. It's looking at all of those squares one at a time. Are you part of a new deposit I haven't seen before? Are you part of a new deposit I haven't seen before? Everyone that says yes gets counted. So 2 times, exactly 2 times, all of the deep recursive calls of dry up on 92 are going to return 1 all the way back to the public wrapper. The first time it sets deposits from 0 to 1. The next time when it runs into this one it hasn't seen before, it's going to change deposits from 1 to 2. Grand total. It's looked at the entire grid, and when it gets back, it will eventually, in this case, return 2. It's found 2 deposits total, and it looks through all of these 6 squares here. That's what it's doing with those nested loops, offset to account for the bouncy wall. Lots of stuff to absorb. Oh, and I said we're ignoring the return values of dry up on all of those little neighborhood recursive calls on line 73 through 80. Be wary, you're not going to do that in program 2. You do need to look at the return value. And we'll discuss why when we talk a little more about what on earth we're going to do about that program 2. Well, with that perilous, ominous sounding thought, I think I'm going to stop here because the hugest can of worms in this entire class is next, and I think that probably is going to deserve its own video. So I will see you online.